everyone. In this video, we're going to look at the cosine law, which is how we can solve oblique triangles or non-right triangles that can't be solved using the sine law. So again, I have my triangle ABC with sides and angles labeled with corresponding letters of the alphabet, either uppercase or lowercase. And I think about when I can use the sine law. So I can use the sine law if I know a pair of angle and side that are opposite to each other. So if I know the side A and angle A or so on. But if I don't know a pair of opposites, so this would happen under two sets of circumstances. Well, three sets, but only two in which we can solve the triangle. So the first set of circumstances is if I know all three sides. If I know the lengths of all three sides, but none of the angles, then I can't use the sine law because I can't establish a single proportion. Or if I know the side lengths of two sides and the angle that is between them. Oops, I'm using C because my brain is thinking in French where côté is side. But all three sides, S for sides, and two sides and the angle between them. So SAS. So for example, if I know side A and side B, and then I know the measure of angle C, I can't use the sine law because while I know side A, I don't know angle A. I know side B, but not angle B. And I know angle C, but not side C. So if I know that, then I cannot use the sine law. The third situation is the situation in which I know all three angles, but that is not a situation in which I can solve the triangle. I need to know at least one side to be able to solve the triangle. So if I have one of these two situations, then I need to use the cosine law. I'm not going to go and show the proof for the cosine law in this video. I will show that in class. If you're curious about it, you can, there are other videos on YouTube that show it. So there's two different arrangements of the cosine law. One of them says that a side length, so let's go C squared equals A squared plus B squared. So far this starts like the Pythagorean theorem, which is only applicable in right triangles. And notice that I'm using C. It doesn't necessarily have to be the longest side, whereas in a right triangle, it would be the longest side. So C squared equals A squared plus B squared minus 2 times A times B times the cosine of C. So this actually is a more general form. The Pythagorean theorem is a special case of this. The Pythagorean theorem would basically be what happens if angle C is 90 degrees. Because if angle C is 90 degrees, the cosine of 90 degrees is 0. So the entire last term disappears and we end up with just C squared equals A squared plus B squared. But this form of it will now work in any triangle for any of the sides, regardless of whether I have a 90-degree angle or not. And the alternate form of this, so this would be the form I would use if I'm trying to find a missing side length. So that would be if I have the SAS form. I know two sides and an angle between them. If I know all three sides, then I prefer the form that says cosine of C equals A squared plus B squared minus C squared divided by 2AB. This is just what happens if I rearrange that first formula. The thing to note here is that A and B are interchangeable. It doesn't matter which side I call A and which side I call B here, but the angle I'm trying to find has to be opposite to the side length C, the one that is being subtracted, or in the alternate form, the side length I'm trying to find has to be opposite to the angle that I'm using. So let's look at this in practice. So here we have a triangle where we have the SAS situation. I have a side, I have an angle, and then I have another side. The angle is between the two sides. So I'm going to start by finding side B. So B squared, that's the side. Well, B squared equals the sum of the squares of the other two sides. So 5.5 squared plus 5.8 squared minus 2 times these sides, 2 times 5.5 times 5.8 times the cosine of the angle B, which is 101 degrees. I'm going to note that I'm expecting to find a side length that is bigger than either of the two others because 101 has to be the biggest angle. And then the other thing I'm going to note is that in most of your calculators, it is the best idea to just enter this all in one step. Sometimes people try and get clever and they do this in multiple steps and then they end up breaking the order of operations. The most common error I see is students would go 5.5 squared plus 5.8 squared. And then minus 2 times 5.5 times 5.8, and then they hit enter, and then they multiply by the cosine of 101. But that's not the correct order of operations because all of these need to be multiplied together before they are subtracted. But for the most part, your calculator can handle that. So just enter this all in one step, and when you hit enter, you end up with b squared is approximately 76.1. That's not b, I have to actually now take the square root of that. So when I take the square root, I get b is approximately 8.72, which is longest, which is what I was going for. So 8.72 centimeters. Now I have all three sides, so I'm going to store that value in my calculator so that I can use it later, because I'm going to need to use it to figure out either angle A or angle C. And I don't want to use a rounded value, I want to use a stored value. So let's go with finding angle A. So to find angle A, the cosine of A equals. All right, so now I need the squares of the two sides that are touching A, that are on either side of A. So that would be 5.5 squared plus this 8.72. Now I'm writing a rounded value in my formula here, but in my calculator, I'm going to use a stored value. And then I subtract the square of the side opposite to A, which is 5.8. So minus 5.8 squared, divided by 2 times 5.5 times 8.72. So the 2 is part of the formula, and then I put the side lengths here. Again, enter this all in one swoop in your calculator. Some of your calculators will let you do it as a fraction. Some of you have to use brackets, bracket your entire numerator, and then bracket your entire denominator. But I've got 5.5 squared plus that value I stored. I'm not just using 8.72 squared minus 5.8 squared, and then divided by 2 times 5.5, and then again times the stored value, not the typed value. And what I get when I do all this is I get approximately 0.7575. Again, that is not A, that is the cosine of A. So I need to use the arc cos, or the cos -1 button on my calculator. And what I get is that A is approximately 40.8 degrees when I round to 3 significant digits. So 40.8 degrees. Now to find angle C, I could do the cosine law again. I could do the sine law if I wanted to, but the easiest way to do it would simply be to subtract the angles from 180. So 180 minus 101 minus this 40.8 that I just found. Again, I'm using the answer key on my calculator, not typing in a rounded value, partly because it's more exact, partly because it's quicker. So 38.2 degrees, which makes sense. That's the smallest side length, C, and so I'm expecting angle C to be the smallest angle. Now, I could have found the measure of A using sine law. Sine law also would have worked, but I'm trying to illustrate cosine law here. So sine law is an option. Once I know the length of side B, then I did have a pair of opposites, so I could have used the sine law. All right, now let's say I'm starting with all three sides. So starting with all three sides means I'm going to have to start using the cosine law. I am going to recommend starting by finding the biggest angle. The biggest angle in this case is C. The reason I'm going to recommend that is because after I find the biggest angle using the cosine law, it's nice to be able to use the sine law to find the other angles. It's a little bit quicker. But in order to do that, I have to make sure that I'm not getting myself into a trap where this is a case where the sine law can actually give me two triangles. By using the cosine law to find the biggest angle first, we avoid that trap. So let's find the cosine of C. It is going to be the 38 squared plus the 29 squared, so that's the two sides on either side of C, minus 45 squared, because that is the side opposite C, divided by 2 times 38 times 29. So again, I enter that all into my calculator, bracketing the whole numerator if necessary, bracketing the whole denominator if necessary, if your calculator doesn't let you do it as a fraction. And when I multiply all those together, I get about 0.11797-ish. So arc cos of that tells me that angle C is approximately 83.2 degrees. I should probably mention, if your calculator is not in degree mode while you're doing this, you will be getting answers that maybe don't make any sense if you're in radian mode. If that happens, double check the mode of your calculator. So I have 83.2 degrees here. Now I can go ahead and find A or B. It doesn't matter whether I find the next biggest or the smallest or whatever. And I could use cosine law again. As long as I continue using cosine law, I don't have to worry about potentially finding the wrong angle, which sometimes does happen with sine law. It will not happen in this case with sine law because I found the biggest angle first. So I can go ahead and use sine law. So I'm going to find angle A using the sine law. Sine of A over 38 equals the sine of C, which is 83.2 degrees over 45. Now, again, I want to use a stored value, not a typed value here. So sine of C, which is a value I stored, divided by 45 times 38 will give me the sine of A, which is approximately 0.8385. And then when I do the arc sine of that, I get that angle A is approximately 57.0 degrees when I round it correctly. So 57.0 degrees. At this point, I don't need to use sine law or cosine law to find B. I can simply add A and C together using my stored values and then subtract that from 180. And so I get that that is 39.8 degrees. And I have solved that triangle using a combination of sine law and cosine law.